Hi, now we'll discuss about the rich comparison. Now, this rich comparison means basically we want to compare the element like less than, greater than, less than, equal to, greater than, equal to, right? Not equal to. All these considered as a rich comparison, right? So now if one comparison does not exist, right? So Python will try to reverse the operand and the operator. That means if you have implemented less than, right, and then you are trying a to object with a greater than operator, so it will reverse and it will flip and make it to a less than operator, right? Let's see that in Excel. So let's use this 2D vector over here. So here we are getting a vector class. We have this two element x and the y. We have the two axes of the vector x and the y, and then we have this REPR method. Now here we have this two object. The idea of the both objects are totally different. When we try to see v1 equal to v2, what this will do is this will give you false. This is not giving you error. Why? Because by default Python use is operator when it does not find this equal to operator implementation is there in the class. We have not implemented the equal to operator, so it is using is operator, and because v1 and v2 both are the different objects, so it is returning false, right? So they are not comparing the element, right? Now let's change it, and here we are implementing the equal to operator. Now in this equal to operator, we are first checking whether this other object is belong to the vector class or not. And then if it is true, then we are returning x of the both object and the y of the both objects are true or not. That means if x of the both objects are same and the y of the both objects are same. If both are true, then it will return true. Otherwise, it will return not implemented. Right. So let's see that. So this will return either true or false, right? Now here we have this three object we are creating v1 and v2. Now first we are trying to check v1 equal to v2, and now we are checking v1 is v2. Now this will return false because v1 and v2, though they have the same element, right? But both are the different objects. So this will return false, but this will return true because both have the same element. Right, let's see that. Here we're getting that. When we see v1 equal to v3, this will give you false because the elements are different in v1 and v3. Now we could even support the equality comparison with other iterable types, right? Like here we are supporting with the tuples. Let's say that the other, like here we're checking that if the other object belong to the tuple class. So what we'll do is we'll take the others, we'll convert it into a vectors, right? Now the other object is a vector now. And now we are checking if the other object is a vector, then we'll try to compare their elements, right? So if you pass or if you try this equal to operator with the vector, it will first convert it into a vector and then try to do the like then it will try to do the equal to operator, right? Let's run this. Here we have this vector 1. Now we are trying to compare v1 equal to 10 comma 11. This means that we are passing a tuple. When we try to do this, we are getting true because first it is checking the other object is tuple. It is converting to a vector. Now it is checking whether this other has been converted to a vector now, and now it is comparing the element. And then based on that, it is returning true and a false. In fact, when you do this tuple equal to v1, when you do this, this will be true. Why? We have not implemented this tuple equal to true over here, right? Because Python will reflect the operations. That means we can also implement the other rich operation in the same way, right? So here we have this. Let's implement the less than operator, right? Now we'll consider a vector to be a less than the another vector if the Euclidean distance or if the length is less than the other vector, right? So we'll see the less than operator, right? We'll check that whether this vector 1 is less than vector 2 based on their length, right? And to calculate the length, we'll have to use the absolute functions. So we'll have to define the absolute function as well over here. Let's see that in Excel. Here we have this vector, we have this equal to operator. Now we are implementing the absolute functions. Now this function is like taking the each element, taking the square of each element, adding it, and then taking the square root. That is what the absolute value will give you, right? Now again in the less than, first we are trying to check whether this other is a tuple converting to a tuple, converting to a vector, and then we'll check that other has been converted to a vector or not, and then we'll check whether this absolute of self is less than absolute of other. If it is, or like if it is true and false, it will return that. Right, let's do this. Now here we have this 2 vector. Now we are checking whether this v1 is less than v2. It is true. Now let's see what happens when we do v1 is greater, v2 is greater than v1. Basically, this is saying the same way, right? Either you say v1 is less than v2 and v2 is greater than v1. But this thing has not implemented. v2 is greater than, so greater than operator has not implemented. But when we do this, it will return true. Why? So when we do this, we know that this greater than was not implemented. So Python decide to reflect the operations. That means instead of actually comparing v2 is greater than v1, it is actually running v1 is less than v2. So it is, so Python has flipped the operand, flipped the expression, and then it is checking whether this v1 is less than v2, which is the same thing. So Python is being smart over here, right? What about the tuples? When you do this, it is working. It can also do the reverse, right? That work. Now, how about less than equal to? Since we already have less than and equal to defined, Python is able to use both to come up with the result. We have these two objects, v1 and v2. This is a v1 object and this is a v2 object. Now let's try v1 is less than equal to v2. When we do this, it is giving you unsupported operands. That means it is not supporting. So basically we'll have to implement this less than equal to operator, right? So let's implement it. So here we have this, again the same code. Now in the less than equal to, we'll simply say whether this, like we'll simply use this equal to and less than operator. We'll say that self is equal to other or self is less than other. If either of the true are, so it will turn true, otherwise it will turn false, right? So we'll see that, right? So this has implemented. Now we are using only two operator, less than and equal to, and now we are implementing the third operator, right? Now let's create the three object over here. Here we're saying v1 is less than equal to v2. Now it is using this, it is calling this less than equal to method, and now under the hood it is using equal to or less than operator, right? Now we can see that it can also do with the tuples. What about greater than equal to? It is also working as well. So again, it has done the reverse operations, right? So instead of v1 is greater than v2, it is saying v2 is less than equal to v1, right? We can also see this not equal to operator. When we say v1 is not equal to v2, it is giving you false. Now remember, this not equal to method has not implemented. So it has used the equal to, and then it has used the not on that. So first it has used v1 is equal to v2, whatever the output is, and now it is saying not of that output, and it is returning you the output. So this again, the Python is being smart over here, right? We can easily see, like here we have changed this equal to operations, right? So when we do this not equal to, right, it, we can see that this equal to is being called over here. Let's see that we have this two vector. When we run this, it will call the equal to operator. Can you see this? So in many cases, we can derive the most of the rich comparison from just two base one. So we have implemented the two base method. One is equal to and other one can be less than or less than equal to, or you can implement any method. So for example, if you have this equal to and less than defined, so all these things can work, right? So if you try to do this, it will check this, right? If you try to do this, it will check this. If you try to do this, it will check this. If you try to do this, it will check this operator, right? So just the basis of only two operators, right? You can do a lot of things, right? But instead of defining all the various methods, we can use this total ordering decorator from the func tools modules, right? That will work with the equal to and one other rich comparisons. So we'll have to do that. So here again, here remember that we had to implement the less than equal to, but when we use this total ordering, we do not have to implement the less than equal to operator as well. So here in the, again, we are creating a new class. We are creating a number class. It has just one object X. We are implementing the equal to method, and now we are implementing the less than method. right? We have just implemented the to method and that's it. And now we have attached this total ordering decorator over here. When we run this, now let's create a 3 object over here. Now when we do this, A is less than B, A is less than equal to B, we have not implemented less than equal to, we had to write a code for that, but we are not writing it. But when we do this, we can see that it is doing, right? This is because of this total ordering, right? Decorator. Now when we see A is less than equal to C, we can do this, right? So everything is being called, right? So this is it. This is all about the rich comparison in Python. Thank you very much.